So, alright, welcome back, guys. Let's start again. Uh, Secrets. So, what we did is yesterday we written raw SQL, right, and created a table with a schema there, and we inserted some data and selected, and after that we dropped it also, right. So it was just a handwritten SQL there in the PSQL. Okay. So PSQL is a REPL for SQL, like just like Python. Read, execute, print, and loop. Okay. Now next thing what we will do is first we have to activate the virtual environment. And we have done this, and after that first we have to install the SQL alchemy, right, because we don't want to run write SQL again and again. Okay. So pip here, install SQL, okay, alchemy, right, and DINA here, and also we have to install this Python dot environment. Okay. So it's done, and we have to freeze this in requirements.txt. So what we did here, let me explain this. Okay. So what is PIP? Let's understand this also in detail. Okay. So think of PIP as the Play Store for Python. Okay. Like you have Python, and then you have PIP, and you have some downloadable libraries. Okay. Downloads libraries. So when you run any command with PIP, so what PIP does, PIP downloads and install these libraries for you, like we did here, right. These are all libraries. This is Play Store for Python. What we install? We install SQL alchemy, Psycho PG2 binary, and Python.NET env. Okay. What is this SQL alchemy here? So SQL alchemy is the ORM. Okay. We were discussing that yesterday also. It's the ORM, which called object relation mapper. Okay. Relational mapper. If it is sounding complicated to you, what is this? But the idea is very simple. Okay. So imagine you have a database table like this. This is ID. You have text as yesterday, and you have some like created at. Okay. Created it like this. Okay. Like 1, 2 text is good product and good and bad, just like this. Created at some, okay, 10 p.m. let's say, and this is 11 p.m. Just a time. We are not writing date. Okay. So what you do normally for this to retrieve this data, normally what you do, you write this SQL like this, right? Select asterisk from, let's say the name of the table is users. Okay. So from users. So these both rows will be selected. Okay, these both rows will be selected in this case. But with SQL Alchemy, you can use Python instead of this direct SQL query. Okay, what you can do? You can use Python like here. So with ORM, or in case you can say with SQL Alchemy. What you can do is you can do users is equal to session dot query. Okay, and you can user dot, you can say all, like this. So what it will do, these are the users. Okay, from session dot query you are sending the query to the user table and you are selecting all of the users. Okay, this is the function. So this what SQL Alchemy do is it automatically converts your Python code into SQL. Okay. So that's what it do. Imagine, let's take this analogy. Okay, let's say you are visiting Japan, but you only know English, right? Which is like English is comparable to okay, just you understood what I am doing, giving you advices here. It like also let's continue with the analogy. And you only know English, okay? And the shopkeeper in Japan only knows Japanese. So you need a translator, right? So here you are Python, okay? And shopkeeper is database, okay? Database only understand SQL, okay? So you need here SQL Alchemy as your translator, which converts this Python to SQL. Okay. So this is what ORM is. ORM, you understand the relation, what is referring, what is this meaning of object relation model. So object is our this table, relation is this table, object is our this command, I think, and the mapper is mapping between them. Okay. So objects are like classes in Python, right? So Python only understands objects. So instead of thinking about tables, what you do, you work with normal Python classes. Okay, like this. For example, let's say user is equal to user name is equal to Sunil, let's say, and age is, let's say, 23, right? So instead of writing this is your Python object, right? This is your object and this is in Python only. What is the equivalent SQL for this? Equivalent SQL would be like we have to insert something, right? Like insert into users, right? And we have to do this name and age, and we have to specify the values also. Values, one is Sunil and then 23. So you have to do this, right, in SQL. So what it do this SORM, or you can say ORM, generates this for you. Okay, generate that for you. That's what is. And next thing we install here is what? Psycho PG2. Okay, binary. Okay, what is this? Co PG2 binary, right? What is this? In simple language, it's a PostgreSQL driver. Okay, that's what it is. Okay, so what is a driver? Let's go with this very basic thing, right? What is a driver? So imagine SQL alchemy wants to talk to PostgreSQL. Okay, you can say, let's take the analogy. Okay, imagine SQL alchemy, right? This wants to talk to PostgreSQL database, right? Database program. It wants to talk to this. So SQL alchemy know what to say, right? It knows what to say. It can write the command, right? But it doesn't know how to physically send the message, right? But it doesn't know how to physically send a message, right? It doesn't know that. So it needs a driver. So think of this analogy, okay? You want to send a courier for a friend, right? You know what to send, but you will not go there, right? So you are here, you need a courier service, right? Then you send this to friend. So this courier serviceman actually carries the parcel, right? So similarly, what happens is you have a fast API, right? Fast API. This fast API communicate with SQL alchemy, okay, with Python object, like this, okay, like this, okay. So this talk with this. Now this SQL alchemy will communicate with what? Psycho PG2, and this will communicate with the PostgreSQL. Okay. So what it do? This psycho, this thing, okay. It let me do this. It carries SQL commands between your app and PostgreSQL. Okay, this is why we need. This is very important. This is our driver. Okay. So you can have a question, right? Why can't SQL alchemy do everything? So the thing is, let me write this in very red. Why can't SQL alchemy, right, do everything? So the problem here in this is SQL alchemy is designed to support many databases, okay, like PostgreSQL. It support this. Also, it's also support MySQL. It supports SQLite. It also support Oracle. It also support SQL Server, like this. So each database speaks a slightly different language over the a network, right? So instead of learning every database protocol itself, right, what it happens is SQL can ask the appropriate driver to communicate, like appropriate parcel service, right? So drivers are different for different databases. Okay, so like I can write it here like in magenta. Every database has different drivers. So SQL Alchemy needs appropriate driver to communicate with different databases, right? Like this. So in this case, this PostgreSQL database DB has psycho pg2 as driver. Okay, you understand this? And so let also one more thing I think. So let me explain the flow of this with an example. Okay, you run this session dot query, okay, users or user dot all. You run this query, right? What happens? You have this Python code. This Python code goes to SQL Alchemy. So this SQL Alchemy translate this Python to SQL, right? Converts to SQL. Then this SQL goes to like let's this also select asterisk from users. It's converted. This SQL command goes to psycho pg2, right? Then what happens? From here this it sends SQL over the network, right? And this goes to then PostgreSQL. All right. And next thing, guys, we installed was this Python dot environment, right? So that's also very important. Let me show you this thing, Python dot env. Okay, what is this? So what happened? This will load a file called .env. Okay, automatically loads a file called .env. So I also told you yesterday what is env file. So let's say, let me explain this again also. This env file, okay, .env file. So suppose your database password is this, my password 123, right? You have this password. So you cannot write this password directly into your code, right? Like, okay, my password is this. So what you do, you keep a secret in a separate file, which is called the .env file. Okay, so .env file could look like this. This could look like this. db users is equal to Postgres and db password is this, my password 123, like this, right? And db name is reviews. So so what it does, now your Python code will read those values, okay, with this this command is this load dot env, okay, by this function. After that, what happens is os dot get env, you will run this command. After that, you will run this command os dot env, and you define like this db password. So it will access this password from the env file, and it will return this. It returns this my password. You can see this. It will return this. Okay, my password 123. So imagine you are working in a team. Okay, each developer may have different settings. Like me have db name as reviews, and other user, let's say Rahul, has db name as test reviews, right? So neither has to edit the source code. Okay, each person keeps their own environment files, and also keeps password and APIs out of the Git repositories. Okay. Next command we run here was this pip freeze requirements.txt, right? That's also very important to understand what this command is all about. Okay. So what is this pip freeze, right? Let's understand this pip freeze. So it lists every installed Python package and its version. What it does is, you have this Python, it's just a play store for Python, right? Python play store, and this freeze is a command. Okay. What it does, it lists every installed Python package and its version. For example, fast API have some version, right? Fast API is equal to will be like this 0.116.1, like this, right? And SQL Alchemy can have also version, right? Let's say 2.0.43, like this. So everything is have version. And UV core also have some version 0.35.0, like this, right? So it will list them out. Okay. And after listing those them out, what it does, we are what I doing in the command. The command was this command was this, right? Pip freeze requirements .txt, right? .txt. So this is our requirements.txt file. You can see everything is listed with its version, right? So what is this right arrow means? Okay. So this defines we have the list with versions, and this will take the output, which is list, and write it into if file. Which file? This requirement.txt, right? Output is here. Okay. So that's how. So we need this requirement.txt. Like suppose your friend clones your project. Okay. Without this file, what will happen is, if your friend run the project, right, it will encounter this error, module not found error. Okay, because they don't know which package to install, right? So by specifying the requirement.txt, they simply run this command. When they clone it, they simply run pip install are requirements dot txt, right? So the PIP will install the exact versions your project needs, right? Like this. So I think you understand everything here in this case. Okay. So let me create a secret file, right, first, because I don't know it is there, right? Okay, so let's add these things. Okay, so in the project root we can, because this already ignored, right? .env file is already ignored, and we install already this python.env, right? So let me create this one file, .env. Okay, this is .env file, and let me write some secret here, like database URL. I will explain everything you do to you what is I am doing. Okay, let me write it first. Post GraceQL, right? PostgreSQL. Okay, radar and radar dev password at localhost, right? 5432 is the default port, right? View radar. Okay. So it's a connection URL, right? So this one string is carrying everything. Uh, so this is for protocol. So we are connecting with PostgreSQL. This is the table name, okay, user, which is the radar. Radar is the username, and then it is his password. So radar dev password is just I used here. Then host, local host is there, and port is there, and the database name. So database is review radar we created yesterday, and user was radar, like this, right? And PostgreSQL is the protocol. So this one URL is working everything, okay? Why only one URL here instead of five variables, like, okay, what is the protocol, what is the user, what is the password, what is the port, what is the host, right? And what is the database. So it's just a universal convention on the every cloud, okay? So let me before I explain everything here, let me show you one more thing if I forgot. Okay. Okay, and the thing get status. So let me show you something. Okay. So everything is modified. Dot ignored, requirement to dot txt is ignored, right? Many files are ignored, right? But this dot env file is not visible here, right? As you can see. But what I can do in dot ignore, if I remove this, right? Wait. If I comment it out, okay, and now if I do get status, okay, status, then we have this .env file, okay, in untracked files. So you can see now get can see it. So we don't want that. So what we will do, we will uncomment it, and now we do get status. It's not an untracked file, right? So the production was waiting. We already implemented that. This is why you set up guardrails before you need them. Okay. So that's why we are using this .env file and database URL here. Let's say teammates and your future you work with somewhere, right? This is just a professional convention for every project with secrets. Okay. So let me tell you one more thing. Okay. So what is this everything here, right? Let me tell you everything. With patience. So we created .env file, right? And so this is a long string, okay, in Python, which tells Python how to connect to database. Okay, so this is like a database URL, right? Is like PostgreSQL, then this is the protocol, right? Like HTTP, right? We have then colon, then we have // right? And then we have user, radar is the user. Then we have password, user and password, you can say username and password, you can say. So radar dev password, this is the password thing, right? And then you have the host, which is localhost. Localhost is 127.0.0.1, I think, right? It is the one. And the port again, then you have 5432 as port. Then with / you have the database review radar. This is the database, right? This is how you connect. So what this protocol, this tells like your application use PostgreSQL. Okay, this will tell this. So think of it like choosing a language, right? Like English, Hindi, and right. So this is PostgreSQL language, right? So this will tell your application that you have to use this language for PostgreSQL. Okay. So this application will now know that I should connect to the PostgreSQL database, right? Then this radar, it's just a username, just like you logging into a Gmail, something like that, right? So username is radar here, and this is the password, right? To connect to database, you need password, right? So this will prove like, okay, I'm allowed to access the database or not. And this at, it is just a symbol. It will separate username plus password, right? Username plus password from the location of the database. Okay, where is database running? It is in the background or localhost on this port with the name review radar. So we have to run this in background on this same computer. Okay. Okay, localhost is 127.0.1, as you know. All right, and this review radar is your database name here. So why we are putting everything in one line, right here, instead of like writing db db user is equal to radar, password is this, host is this, port is this, and name is this, right? So many libraries accept a single connection string like this. So this is easier to pass around. Almost every cloud provided now, okay, and ORM understand this format. So just the popularity, okay. So how Python will read this file, okay. What we will do in our code, we will import like from .env. We have to import this is the Python library we just installed, right? Import load .env, okay, and then it will import the OS also, and database URL will be like this, okay. os.get env. So before everything we have to run this command. Let me explain this. Before everything we have to run this command called load.env. This function is called. Then we can run this os.getEnv called database URL, right? Add there. So what happens is python.env will read this .env file and makes the value available to your program, okay. All right. So one more thing, what you can do, guys, is you can also create a example file like this, .env .example, and there you can define or declare like this: database URL is equal to PostgreSQL is the protocol, right? and then you have radar as a user, then you have password also, which is okay. So we are not saying everything, right? We have just, so you need user, then you need password, right? You are telling everyone like then you need local host 5432, right? Slash review radar, right? So user and password will be the different for different users. So you can publish this to Git, right? So if I use Git status here, you can see .env is untracked. So when I push this, okay, so then teammates can learn what's needed without ever seeing the real values, right? So this is just a professional convention for every project when you are having secrets there, right? Now, very important thing is so we can push this, right? Teammate will know like what we need to connect to database. Okay. All right. Then next thing what we will do, guys, is we will create a file and source and review radar slash db.py. As you can see here, db.py is created, and let's communicate with it here. Okay, what this file is about. So it's just a database layer for review radar, right? Connection tables and persistence. Okay. So first what we need to import logging, so this file will be your database layer for your application. Okay, think of it as a bridge between your fast API application and the Postgres SQL database you are running in background. So how can we run this? Let me tell you how can we run this. Wait a minute. Show the service PostgreSQL start. Okay, so in background we can start from this. Okay, sudo system ctl start PostgreSQL in Linux, and this command is for window users, WSL user. Okay, so whoever is WSL user, window user in WSL, you can run this command sudo service PostgreSQL start, and for Linux user this is the call sudo system ctl start PostgreSQL. Let me run this for you. It's asking my password. Okay, it is running on background. Okay, if I try to run this again, it will say okay, the server is busy. Which port? The port is busy. Which port? 5432. Okay. Okay. What happened? Wait a minute. if I run this, wait a minute, just a minute. If I run this, okay, and same thing I run sudo u postgres psql, okay. Source png build activate sudo what happened, u postgres sql, okay, u postgres sql postgres psql, okay, postgres sql sql psql, okay, so postgres psql, okay. Sudo u post sudo u postgres psql, this is the REPL for that. So you see it's already running there, and it's already running there here. So why it is not like giving me error for the port usage, right? Because it's already running there on that port, right? If I control slash q, if I do this and I run this command, wait a minute, in different terminal I do run this command, call this, okay. It's running in background and it's running in here, so what is happening, guys? So it must have given me the port running error, right? But it's not giving, I don't know why. We will continue from it, okay? So think of this DB file as your layer, database layer of your application. Think of it as the bridge between a fast API application and the PostgreSQL database, right? So overall architecture will become like this. From now, like this, you have your browser, right? Then that browser will communicate with the fast API, right? Then this fast API will communicate with this database.py, because this is the DB file, okay. Let me see your database.py, which is in our case this is db.py for us, right? db.py, and then this db.py will communicate with SQL alchemy. Fast API is the Python object, right? This will communicate with this. This will communicate with this SQL alchemy engine, and this SQL alchemy engine will communicate with the PostgreSQL database with help of what? Psycho PG2, okay, with help of this. You understand it now? So we have this doc string here, okay. It will describe, okay, what this file does. This file is responsible for like connecting the database and defining the tables. This will define some tables, it will save some data, basic persistence, right? Now here we are importing logging, okay. So this will import this Python's logging module. Like you can log any information like logger.info, Python is connected instead of print command, okay. So logging is used in real applications because it records messages with timestamp and different labels like info label, warning label, error label. So you can define labels here. Okay, that's one more advantage of it, and timestamp also. Okay, and next thing we are importing OS. So the OS module lets you play Python, lets Python play, interact with the operating system. Okay, so when you run a command like os.get env, right, and database URL. So you are asking operating system, okay, do you have a variable named database URL there, right? Like this. Okay. Now what we will do, we will import from .env module, right? .env module. We will import this package. Import load.env. Okay. So we are importing this function that reads this will read your .env file. Okay. Without calling this load.env, Python cannot see this file automatically. We have to run this function. Okay. So we have to call this function. Then next thing we have to import from SQL alchemy. Okay, we have to import this. Import float. We have to enter integer because our tables and those all have these data type, right? Text, and one more thing, create engine, and then from. Okay, so this integer is for integer column, right? String text with like limited length. When you define some limited length, this text column is you will use for the long text. Float is decimal numbers. Okay, and this create engine from SQL alchemy, it will connect this SQL alchemy. Okay, this SQL alchemy engine with the database, which is PostgreSQL. So we need this engine, right? And this function, SQL function like count and now will be used in this case. Okay, this is the function library, and we will import that. Then we will import this ORMs also of the SQL alchemy. So from SQL alchemy, we have to import .orm. Okay, import declarative base and mapped. Okay, and then mapped column. Then we have session. Okay, so what is this? These will help us to create tables, okay, using the Python classes here in this, because this is db.py file, right? So we will use Python to use to create classes and create tables. Okay, you think of it as like ORM toolkit. Now then we will import from SQL alchemy. We can import date time also. Okay, so this will allow us to store date and time in tables. Okay, and one more thing, we have to import the Python date time also. Date time, import date time. So this is Python's own date time type. So this it tells Python that created at stored at date time object. Okay, now we imported logging, right? So we have to create the logger also first. Okay, so logger is equal to logging.get logger Name is like whoever I will tell you. Whatever file is, this is file db.py, right? So this name, uh, wait a second. So this name, right? This will tell when you log any statement. So this will tell which file is this log is coming from. So that's why we are declaring the name here, right? Just a minute, guys. I will be back in a minute. Now, next thing is now we will, as I told you, we have to call this function, right, to get the .env file. Okay, so read the .env file. So next thing what I will do is call this function load.env and like this. Okay, so it will read the .env file, right? So after calling this function, Python now knows that variable, okay, which is stored in this this .env. This now Python knows this is a variable. Like if we want to access this variable, Python knows, okay, there is a variable called database URL exist, and we can access that, right? Otherwise, Python would not know, like, okay, there is such variable exist or not, right? So it read that file, okay, then now Python knows, because it's a Python library, right? Python package, you can say Python module, so it knows now because we install it .env, so it all knows. Think of it just like it is as copying values from the .env file into the program's environment, just like this. Let's say this now venv now knows venv now knows this like your secret. Okay, now you can now you have to read the database, right? So database URL is equal to os.get env called the database URL, right? It's the same here. We have to define the database URL from the okay. It will not go for example file. It all will go for the .env file. Okay, like this. So what is doing this OS, we can access the file with the help of OS, with the operating system, and this will ask, okay, give me the value of database URL. If .env contains that value, okay, then what happens is database URL becomes this this value will be assigned to this database URL, okay, like this. Now check if this like value exists or not, because we don't want any like crashing of the system, right? So if database URL is none, let's say, in that case, so suppose you forgot to create an env file, so then this database URL will be none, right? So there is no value found, that which means, so in that case we have to raise the error, okay, raise runtime error, okay. So instead of letting the application fail later with confusing errors, right, it immediately stop and with a helpful message, okay, like database URL is not set, copy.env example to like this, right? So what we can do as runtime error here, database URL is not set, you can say copy dot env dot example to dot env example to e dot env, right, and fill it in, so we can like go with the like useful message when it fails fast with instruction, okay, like this. Now we will create the engine for SQL Alchemy to connect with the database, right? Engine is equal to create engine with the database URL, okay. So the engine is SQL Alchemy connection manager, which will connect to the database, PostgreSQL database, okay. So think of engine as a taxi stand. You have application, taxi stand is an engine, and you have database. Whenever application needs the database, it asks the engine for a connection, okay. So why not open a new connection every time? That's the case, right? So opening a connection, database connection, is slow. Like request, you give a request to open a connection and close a connection, then you request again, like open connection, close connection, like. So what happened? What should I go to approach is pool of connections, okay. You request once, and you will reuse the existing connection and return it to the pool. This is called the connection pooling, okay. So connection pooling, you understand, you only connect with once with the database and you will request many times. So this is our base engine is created, right? Now let's do base class, base declarative base and pass. What I am doing here, so every table in your application will inherit from the base, okay. So think of it like a template. So let's say this base has this. Let me explain it to you in very detailed view. Okay, this base class has this. It has prediction. it's a template of base class, right? Template of this base class: user, you have product, and you have review. Okay. So what it does, it will help SQL Alchemy keep track of all tables. Okay, like this. So next thing is next class for us is class prediction base. So you see, it's importing from it, right? So this defines one database table. Okay, so there is Python class called prediction, and the database table is predictions. Okay, so you can see is table name is equal to predictions. Okay, what's happening here is, without this SQL Alchemy wouldn't know what SQL table is called. Okay, so in that we need that SQL table name also. This prediction table is one table, one instance is equal to one row. Okay, so a table defined as a Python class. Okay, here ORM translates here, because this is object, right? This will be translated to a table, as we are defining this table name, right? In the SQL Alchemy translator, ORM. Okay, so this class is equivalent to the prediction table for us. Okay, and one instance of this class is equivalent to one row. Now next thing is id mapped. Okay, it will be integer type. Okay, is equal to mapped column integer, and also we are giving the primary key as true. So you know what I have done? So mapped int plus mapped column, it is like modern SQL Alchemy tabbed columns. Okay, so what we are doing in this table prediction in SQL, we are defining a column called id, is of integer type, and mapped column is integer, and we are giving this x like defining constraint as primary key. Okay, primary key is there, and so when you do primary key equal to true, it also auto increments the values, id values, like you wrote yesterday as serial. So instead of serial, you don't know need serial here. Okay, so you do yesterday in predictions. So primary key means like no two rows can have the same id. Okay, next thing is this text column. Okay, it's also mapped I think str. Okay, equal to mapped column text, and nullable is false. I think we cannot keep it empty, right? False here. And next is our sentiment, right? Mapped as str, it's limited, I think, right? Equal to mapped column is string. nullable is false in this case also, right? Also we can define string maximum length for string also. And one more thing is index is true in this case. Okay, so index true here means like you can make example it like from the book index theory. Okay, so on the column we will filter by most so many negatives. Okay, so sentiment we can filter out, read get fast, so that's the trade we choose knowingly here. Okay, so this string 10 like maximum length of characters in this case. Next column will be confidences. So we are just creating the same table we dropped yesterday. Okay, complete mapped as a float here. Okay, mapped column in this case float, label is false. Okay, and next thing is created it, and mapped is date time is equal to mapped column date time comma server default is equal to func dot now. Okay, so this server default is equal to func dot now is like database stamp. So here database stamp the time. Okay, not Python here. So this is for database, but this is for Python. Okay, so one clock the DB server, not many app clocks, right? Consistent ordering guaranteed here. So this is the database clock we are using. Okay, so this function now means like database write the current time, not Python. Okay, database will write that current time. Okay, because let's why we are using database time. Imagine the two application servers are there. Okay, server A, their time is 10 and server B has time 9:58. If each server use its own clock, so then timestamp could be inconsistent. Okay, instead, so everyone asks the database only. Okay, not the application server, right? So current database, current time used by every row here in this case. Okay, now next file is here this def init db none. What is this? So it will create all tables that inherit from base. If they don't exist yet. Okay, base dot metadata, right? Metadata dot create all engine. So what happens here, it will look at every class that inherited from base. Which class is inheriting from base? This prediction class, right? Only prediction class is inheriting for now, right? From base, and then it will create the table this predictions. So engine is what? Uh, it is connected to the database, right? So with the help of engine, it will create all the classes or tables, all the tables which are inheriting from the base. Okay, it will create all the tables. If it does not exist, then what we can do? We can log a error basis. In that case, logger dot info, right? Data database tables ready. Okay, create all is fine for now. Changing columns later needs migration, right? So we can flag it honestly on stream. Next we can save predictions. Okay, we can define this class like def save predictions. Okay, text str is a type in for text, and we have sentiment as a string, or we can say str also, and we have confidence as float, because we are using Python here, right? And it will return none because we are just saving. Okay, so we have to persist the one prediction, right? Whatever prediction is there, we have to persist with that, right? We have to save it into database. So this will be a function our API will call after every prediction it made. Okay, so with session, okay, session is a function here, engine as session. Okay, with the help of engine we are connecting to the database, right? Like we were understanding here in the call. Let me explain here. So session dot query like this. So session is the this thing. Okay. Just a session is a conversation with the database. Okay, application will connect to session, session will connect to database using the engine. So using with here ensure the session is automatically closed even if the error occurs. Okay, so we are using with here, right? So that's session will automatically closed. Okay, next here next thing is session dot add. Okay, prediction text is equal to text. Okay, and sentiment is equal to sentiment, and confidence is equal to confidence. Okay, and session dot commit. So ये commit is the transaction complete message, all or nothing in this case. Now durable, because between add and commit, okay, nothing touches the DB. So we have to if crash is there, right? So before the commit, okay. So nothing half will be written, the acid protecting us invisibly here, okay. Then everything will be rollbacked, okay. So this session add prepares a new row, okay. At this point the row is not yet stored, so then when you commit, they actually writes the row to the database, okay. And so this is the prediction, right, base, and everything is giving like id is there. Id will automatically create it because it's a primary key, to it will auto increment. Mapped str we are providing as a text, whatever text we are storing, and we are providing the sentiment, we are providing the confidence. Credit at will be automatically fulfilled, so we don't need to do that. And we are like named parameters is there, right? Okay. Then this commit will actually write to the memory only, permanently saved, okay. Next thing is we have to take this define get recent predictions, okay. Here limit int is equal to 20. It's automatic list of prediction, okay. It will be returning limit here, so it will fetch the newest prediction for the UI for you, okay. With this session engine, with the help of engine, right, with edge session, engine will connect to database, right. This is SQL alchemy engine, right. Return list of session dot query prediction, okay, dot order by prediction dot created at, right, in descending order, okay, like this. Dot limit by limit, right, whatever we have, dot all, right. So this is just a Python method chaining that becomes SQL for us, okay. It's just a select asterisk from predictions, you can say like that, okay. Select asterisk from predictions ordered by created at distance limit is 20, okay. Next code we will define a next thing is get stats function here, okay. So with the, so it will aggregate the counts of the dashboard, okay, for the dashboard with the session or engine, right, as a session here, total is equal to session dot query func, we are dot count, we are using the functions prediction dot id dot scalar here, right, or 0, like this. So function dot count, it will do is just the SQL dot count, okay, and the scalar will unwrap the single values, okay. Then negatives equal to this session dot query, okay, func dot count prediction dot id, okay, dot filter prediction dot sentiment equal to negative, right. You can do dot scalar or 0. Okay, after this what we can do, we can return this dictionary total here, and negatives, right, positive is total as negatives, okay, negative percentage, you can say it will be round of 100 into negative slash total, right, 1 here if total is there, else 0.0, right. So you see here is session.query prediction. It just directly means select asterisk from predictions, okay, like this. We are querying in predictions, select asterisk from query, okay. Order by prediction created at descending order, just newest first, right, equivalent to this order by created at dash C, like this. Limit is there, everything is there, right. So thank you guys for watching. We will meet you tomorrow with the same flow, okay. We will